so today first day we are going to only discuss how the equation, the vector equation of a line is formed. Okay, so basically your chapter has been divided into two portions: vectors, lines, and vectors, planes. So first we will start off with lines. Achha, situation ये है that because now we are in 3D, we are discussing vectors in 3D. So when you talk about the equation of a line, it's not just a y is equal to mx plus c anymore. It used to be a y is equal to mx plus c, a very simple equation for a line, because you were just dealing in a line in 2D. You were just dealing with lines in a plane. So it was very easy to define the equation of a line just by y is equal to mx plus c, where you just needed two things, very simple two things to define the equation of a line, and one was a point on the line and the other thing was the gradient of the line. If you have these two things, you can easily find the equation of a line. That's very simple, you've been doing it since O-level. But it's not that simple in 3D. In 3D, when you are attempting to define the equation of a line, first of all, there are three kinds of equations for lines. You have a vector equation, you have a parametric equation, and then you have a Cartesian equation. But the Cartesian equation, the vector, and the parametric equation come later. First of all, you need to understand how to form a vector equation of a line. If you can form the vector equation of a line, you can easily make it into a Cartesian, and you can easily make it into a parametric equation. The basis is the vector equation. Now, why are we getting into vectors just to define the equation of a line? The issue is this. In 3D, the concept of gradient does not, the concept of gradient does not come from 2D to 3D directly. You have had the concept of a slope of a line, the gradient of a line. You could easily find by taking the difference of the y's and the difference of the x, and the ratio gave you the inclination, the slope of the line. But it's not that simple in 3D. If I take a line and I just float it in the air in this room right now, so it's in 3D space. To define the equation of this line, I can't use the concept of gradient, because the concept of gradient does not translate exactly how it is in 2D into 3D. So in place of the gradient, I need something else to define the equation of a line. In 2D, in Cartesian or whatever, you will just need a point and the slope. In 3D, you need a point and you need a vector that runs parallel to the line. Only then can you define the equation of a line. See, when you were doing the Cartesian equation in 2D, so you said, okay fine, there's a line, there is a point, and I know the coordinates of this point, जो भी coordinates हैं इसके, x1, y1, and I know how much is the inclination of the line, जो भी इसकी steepness है, that steepness is defined by the concept of slope, which you used to find by changing the next. बस ठीक है, slope भी आ गया, line भी आ गया. So the idea was that if this is a point through which your line is passing, तो इस point से तो बहुत सारी lines गुजर सकती हैं. I can make a line like this, I can make a line like this, I can make a line like this, like this. All these lines are passing through this point. So जो आपकी वाली line है, which is this black one, how do I get to know this line? How is this line different from all of them, which are passing through the same point? How this line is different from all of them is the gradient. This line has a specific value of gradient. All the other lines have their own specific value of slope. So they can all pass through the same point, but they will all have different gradients. So this one, the particular one, the black one that we are talking about right now, this is our line, whose equation I am interested in finding. इसका अपना एक value है slope का. So if you can find that out, you change in y for change in x, then you can easily use this format and you can put the value of m here, and you can find out the c value through putting the coordinates in x and y, and you will get your equation. So you will get that particular line equation. Now, put this in 3D. Now there's a point in 3D, कहीं इस रूम में बीच में एक point है, right? And there can be millions of lines passing through that one point in different orientations because it's 3D. So there can be a line passing like this, like from here, from that end towards this. There could be millions of lines passing through that point. एक specific line है जिसकी equation मुझे निकालनी है. How is that line different from all of them? Now, अब gradient नहीं है 3D because it's not just about y and x. There's a z also, so there's no gradient concept. So now we need something other than just knowing कि वो किस point से गुजर रही है. We need something. Now, in 2D we had the gradient. In 3D, I need a vector that runs parallel to my line. If I know there is a vector, if I know the vector that is running parallel to my line, I can define my line equation. Because see, the idea is very simple. This is the point, and let's say this is one line, this is another one, this is another one, this is another one. There's so many lines passing through that point. But I'm only interested in knowing the equation of this one. I know the coordinates of this point through which it's passing. अब gradient नहीं मैं निकाल सकता, तो मैं क्या करूँ? So what I can do is, I can search for a vector that runs parallel to my line. I can search for a vector that runs parallel to my line. Now see, all these lines that I've made, these various lines that are passing the same point, they all are not parallel to this vector. Only this line that I'm interested in is parallel to this vector. So if that means this vector can define this line for me. So if I were to define this line, I would need a vector that runs parallel to this line. It would be a different vector altogether. If I were to define the equation for this one, I would need a vector running parallel to this one, and that would be a different vector altogether. So every line would have a different vector running parallel to it. Wouldn't every line have a different vector running parallel to it? Right? अब मुझे तो इस लाइन का इक्वेशन चाहिए. So I want to know two things. I want to know from the coordinates of the point through which this line is passing, and I want to know a vector that runs parallel to this line. If I have these two things, I can easily form the vector equation of my line. And once I have the vector equation of my line, I can then form the parametric equation, and then follow from that I can form the Cartesian equation as well. Now the vector equation of a line is given by r equals a plus lambda times b. This is the vector equation of a line. Now, what is this? What is this? What is this? And what is this? There are four things here. This is any point on the line. Just like you have y and x. What are these y and x? जैसे आप लिखते हो एक इक्वेशन लिखते हैं y is equal to 2x minus 3. अब ये x और y क्या है? They're just any point on the line, right? They are coordinates. They represent the coordinates of any point on the line, because you know a line extends indefinitely and it has millions of points on it. Agreed? So this equation basically is giving me a mathematical relationship between x and y, which are points on that line. So if I am interested in finding any point on the line, what I would do is either I would place a value of y, or I would place a value of x, and I would find the corresponding other coordinate, and I would have the coordinates of that point on the line. Agreed? Same analogy is for this r over here. This r is any point on the line. It's basically the position vector of any point on the line. This a over here is the known fixed point that it's passing through, which is this. इसके coordinates आपको मालूम होंगे, because आपको देखिए दो चीजें चाहिए. You must know a point through which your line is passing, and you must know a vector which is parallel to your line. Just like in the other Cartesian form which you've been doing all your life, वहाँ आपको दो चीजें चाहिए होती थी. You used to know the point through which the line passes, and you used to know the gradient of the line. you require these two things. ये आपके पास होता था, you used to easily find the equation of a line. Now, to find an equation, a vector equation of a line in 3D, again I need two things. One, I need a point through which it passes. I need to know the coordinates of that point, and I need to know a vector that runs parallel to my line. अगर ये दो चीजें मेरे पास हैं, I can easily form the equation of the line. Are we okay till here? Are we okay till here? Now, this B that you see over here, this is that vector that runs parallel to your line. So you have to put that in the equation. You have to put the coordinates of the point through which a line passes here, and you will have your equation. R is any point of the, just like you have open mind x over here.
So what is this?
What is it?
So what is it?
What is what?
D.
D is the vector that runs parallel to the line. ये आपका D है. This is the vector that runs parallel to your line. वो आप यहाँ पे लिखोगे. So I'm just giving you an overview of what the equation is about. Now let's start finding the equation.
So what is it?
A is the vector, position vector for this point that your line passes through. और लाइन के आपको पॉइंट के कोऑर्डिनेट्स तो मालूम होंगे ना, ऐसे your line passes through 2, 3, 1. So you know the coordinates of the line of the point through which a line passes. If your line is passing through a point 2, 3, 1, so what would be the position vector of that point? 2, 3, 1. You know the position vector is the same as the coordinates itself. So ये आप उठा के अगर एक ही जगह प्लग इन करोगे, डायरेक्शन वेक्टर आपको पहले ही पता होगा, एक वेक्टर है जो that runs parallel to your line, उसको उठा के आप D की जगह पे रखोगे and you have the equation of the line. अच्छा, now how to construct it? Let's come down to that. Because I was just giving you an overview of what the equation is about. Let's come down to how to build this equation. Because I need to show you how the equation comes out. ये आपको derivation बार-बार नहीं करनी होगी, but in order to appreciate the equation, you need to understand how it comes. Then you know exactly what these values mean. So let's say we have, because I can't show you 3D, so I'm just showing you 3D, but this is a 3D. I mean, I had 3D, that's the most I can do. Okay, so let's say this is the line. This is the line L whose equation I'm interested in. अब ये यहाँ पे end नहीं होती, it's an indefinite line. I'm just showing a portion of it. Okay, so there is a point through which this line passes. Let me call that point A. I already know the coordinates of this point. The coordinates are x1, y1, and z1. When I'm saying x1, y1, z1, that means I already know the coordinates of this point. जिससे my line इसमें से गुजर रही है. Like we had discussed, what two things do we need to form the equation of a line? A point and a vector that runs parallel to a line. Okay. There is a vector that runs parallel to a line. I'll give you that vector. Let's say that vector is this one. This is that vector that runs parallel to a line. I'm going to call it vector D. I already know this vector. The vector is ABC. You have a mark vector here. Now you have your two things with you. Now how do you build the equation? See, this is how it goes. Okay, so you know the coordinates of this point A on the line, right? Which means you will also know the position vector for this point A. Do you remember what a position vector is? A vector that originates from origin and it is directed towards the point. And position vector किसका निकालते हैं? जो coordinates है वही आपका ij के form में, that becomes the position vector, right? If you remember basic vectors. So let me call A, small a, this as your position vector for this point A, which you already know is on the line. Are we okay to here? Any questions? Okay. Let's say there is another point P, a random point P. There are millions of points on the line. Let me just pick any point P on the line, any random point P on the line, which has coordinates x, y, and z, open coordinates. Could be any point on the line P. This point would also have a position vector. Let's call that position vector R. So basically, position vector R is the position vector of any point x, y, z on the line. You're okay with that? Are we all okay with that? Alright. Now, if you remember basic addition of vectors, can I say, okay, let's just list down what these are first of all. So basically, L is your line, A is the known fixed point on the line L, small a is the position vector, small a is the position vector for the point A, P is any point on L, you wrote it in here, R is the position vector for the point P, and D is the vector that runs parallel to the line, which we call it the direction vector. Why we call it the direction vector? Because it is parallel to the line L. So are we copy with it? ये सब कुछ हमारे पास है. Is that no copy here? Okay. Now by basic addition of vectors, can I say that this vector R is equal to A plus AP? Can I say that? Yes, sir. That it is A plus AP, can I say that?
Yes.
A plus vector AP. Let's say there is a vector AP. There is a vector between point A and B. I am calling it vector AP. So can I say A plus AP is equal to R? Head to tail rule, simple addition of vectors. Achha. Do you remember the concept of scalar multiplication?
Yes.
So two vectors are scalar multiples of each other only if they are parallel. Or you can say parallel vectors are always scalar multiples of each other. So if I say there is a vector A which is equal to 2 times vector B, so A and B have to be parallel to each other. So if I am saying A is equal to 2 times B, that means the length of A is twice the length of B, right? इसका मतलब B छोटा है, A बड़ा है, A is 2 times the length of B. Are you all okay with that? Do you remember the scalar multiplication? अच्छा. This vector D is running parallel to your line. Can I use D with scalar multiplication to define AP? The vector AP. If vector AP and D are both parallel to each other, can they be scalar multiples of each other? Can they be scalar multiples of each other? Okay. Then, can I say that as AP vector is parallel to the vector D, therefore AP is some scalar multiplied by vector D. I am calling it scalar lambda. Is it okay if I call it lambda? So some scalar multiple of D, so is that fine? Two vectors are parallel to each other, so one is scalar multiple of the other. Agreed? अब वो depend करता है कि वो scalar multiple क्या है. That depends on many things. That depends on what is the length of AP, what is the length of D. If the length of AP is 2 times the length of D, then I'll say AP is equal to 2D. Agreed? If the length of AP is 3 times the length of the vector D, then I'll say AP vector is equal to 3 times D. So फिर उस केस में lambda की वैल्यू क्या होगी? 3. So lambda value depends on what the length AP is and what the length of D is. So that's fine, right? Are we okay with that? And if AP and D are both of the same length, then lambda is 1. So we are okay with that? अच्छा.
AP change होके D कैसे हुआ?
नहीं, change नहीं हुआ. AP is some scalar multiple times D because AP and D are parallel. So I can always write that the scalar multiples. So if AP and D have the same length, then I'll say AP is equal to D, then lambda is 1. Agreed? So lambda is basically just playing a role of a scalar multiple, and depending on what AP की length and D की length है, lambda accordingly fits that. Are we okay till here? Alright. So can I say hence R is equal to A plus lambda times D. Can I say that? Can I say that?
Yeah.
This is the vector equation of your line. R is equal to A plus lambda times D. Now, it's very simple. Let's take an example. Let's take values. There is a line that passes through a point A whose coordinates are 2, 3, 1. I'm just making up an example. And this line is also parallel to a vector. Let's say the vector is -1, -1, 3. That's it. So what is the vector equation of your line? The vector equation of your line is R equals A plus lambda times D. That's it. That's the vector equation of your line. That's it. To define a line, you need two things. You need the coordinates of a point through which it passes, and you need a vector that runs parallel to your line. That's about it. वो क्यों है वो मैंने आपको भी बताया क्यों है. I just showed the derivation why we need D and why we need A. So that's how A is equal to A plus lambda is constructed. But as now you know, as once it's constructed, you just need to plug in the points and you just need to find the equation. That's it. Are we good till here?
So but जो आपका ऊपर वाला जैसे डायग्राम था, उसके अंदर A was a different line and AP was a different line. हम लोग जो लैम्डा D लिख रहे थे, हाँ, तो हम AP से लैम्डा को AP से D को
मैंने जनरल एक फॉर्मूला दिया लैम्डा D.
So लैम्डा अगर लाइन थी ना तो इसमें हाँ देखो D is parallel to line A.
हाँ D is parallel to line A, line L, yes.
No sir, but in the second diagram, हाँ, वो जो A है पोजीशन वेक्टर आ रहा है, हाँ, उसी के साथ पैरेलल आ रही है लाइन. ये तो मतलब
नहीं, D वेक्टर तो लाइन से पैरेलल है, पोजीशन वेक्टर के पैरेलल नहीं, पोजीशन वेक्टर तो ये रहा. पोजीशन वेक्टर तो ये रहा, लो ये पोजीशन वेक्टर.
हाँ सही है. Thanks.
Are we good? Acha. So this was very simple to construct, but it doesn't end here because I want you to understand what this is. That is very important to understand. कि lambda क्या है? ये lambda आपने ये तो openly की छोड़ दिया बात. See now this is openly left. And now what is this? R. Now see, just like when you used to form the equation of a line, let's say y is equal to 2x minus 3. So why did you leave x and y open? Because they were representing any point on this particular line whose equation is y is equal to x minus 3.
So R is the position vector of this line.
R is the position vector of any point on the line. Acha. Now look at this. R is basically your R is basically just open x, y, z. It's the position vector of any point on the line. If I keep lambda as 0, what do I get R as?
2, 3.
Now, just watch. For lambda equals 0, my R turns out to be 2, 3, 1. So what am I trying to say here? I'm saying there is a point on the line whose coordinates are 2, 3, 1. Yes, there is a point on the line whose coordinates are 2, 3, 1. So lambda 0, basically what you're trying to say is that this D finishes off and you are exactly here. If I put now just watch. If I put lambda as 1, for lambda equal to 1, what do I get?
1, 2, 4.
Okay, so 2, 3, 1 plus 1 times this is -1, -1, 3. I'm getting the answer 1, 2, 4. That means there is a point here on the line whose coordinates are 1, 2, 4. So I found a point on the line. Just like you would randomly plug in values of x to get random values of y, and you would get different points on the line. So here you would plug in different values of lambda, any value of lambda, and you will get multiple points on your line. So you can plug in any value of lambda. You can plug a decimal value of lambda, fractional, negative, positive, any value. You will get different points. on the line. But I just want you to understand कि lambda is equal to 1 पे जो आपका point निकला है उसकी significance क्या है? Can anyone tell me the significance of this point by putting lambda as 1? Now see, the significance of this point putting lambda is equal to 1 is that this point is exactly one direction vector away from your point fixed point A. This point, because this point is formed by putting lambda as 1, this distance between the point that you just found and your original fixed point, this distance is exactly the same length as your vector D. Because जब आप lambda 1 रखते हो तो आपका AP equals to, that means this is your point P, this length is exactly equal to the length of D, so this point is exactly one direction vector away from your fixed point A. Now if I keep lambda as 2, let's say for lambda equals 2, I would get 231 plus ये 2 times, if you get so minus 2 6, you will get end up with 0 1 7, which means there is another point somewhere here, there is another point on the line somewhere here whose coordinates are 0 1 7, 0 1 comma 7. And what's the significance of this point now? It is, yes, the distance this point is from A is 2 direction vectors away from it. So ये जो भी D की length है, अब मुझे नहीं पता D की length क्या है, but कुछ तो length होगी ना D की. So this point is 2 times the direction vector. So whatever is the length of D, which we can easily find. How do you find the length of vector by the way? By finding the magnitude. So can you just do that right here? You find the magnitude D. So the D magnitude is 1 square plus 1 square plus 3 square. X square plus 5 square plus Z square under root. So this 9, 10, 11, that's root 11. Root 11 is how much? Can anyone just tell me decimals kitna है root 11? Just an approximation. 3.32. So it's approximately around 3.32. That means this point was 3.32 units away from point fixed point A, and this point is around 6.64 units away from. अब अगर मैं lambda half रख दूं, so I'll get a point somewhere here. That would be, yes, 1 point something. That would be half the length of the direction vector away from. That's the significance of lambda, and lambda is called a parameter. By the way, these सारी चीजें मैंने यहाँ लिखी हुई हैं. What is lambda? It's called a parameter. Everything is written here. So it's in the notes already. Okay, now did we understand lambda is half, lambda is 1, lambda? Now can anyone tell me what would lambda equal to minus 1 signify? It would be one direction vector. The point that you will get through lambda is equal to minus 1 would be one direction vector away from A, but on the opposite end of it. So if I keep lambda as minus 1, if I keep lambda as minus 1 for lambda equals minus 1, my R value would come out something like 231, and this would be 1 1 minus 3, that would come out as 3 4 minus 2. So these are coordinates of a point 3 4 minus 2, which is on the line, but let me just extend the line a bit. Yeah. So it's a point on the line, one direction vector away from A, but on the opposite side of it. Not on this side, but on the other side. The length would be 1 unit. This point and this point are exactly 1 unit away from, one direction vector away from A, but ये lambda is equal to 1 से आया है. The other one is coming from lambda equal to minus 1, so it's on the other end of it. And therefore, lambda equal to 0 would give you the point exactly on. Are we good? You understand lambda and D? Any questions? Please do ask. I know it's going to take a bit of time to digest, but please look at it again and again, and please ask me if there's any ambiguity in any one of these 4 things here. Yes.
So, lambda minus डायरेक्शन तो ऑब्जेक्ट हो गई।
हाँ, it depends on कि D का डायरेक्शन क्या है। मैंने जो D का डायरेक्शन लिया है is downwards.
Downwards.
So all positive lambdas are giving me points here. If my D was directed this way, my positive lambdas would have given me points here, and my negative lambdas would have given me points here. So it depends on where D is. Lambda is the number of D's that your point P is away from. So if I take lambda as 1, that means my point P that I am finding is one direction vector. Its distance is the length of one direction vector away from the fixed point. So it also depends on what your D is, how long or short is your D. So D you know, so automatically you can tell how much distance would that be from you. Any questions? Guys, we need to understand this completely before I move on to cases. You need to tell me if there is any ambiguity regarding R, A, lambda or D. We need to clear this right now. Because आगे फिर मैं आपको cases की procedure समझाऊंगा, फिर उस वक्त आप अगर आपको इनमें से कोई एक चीज का concept clear नहीं होगा तो फिर आपको procedure में problem हो जाएगी. So अभी totally clear on what R, A, lambda and D is.
Second वाले मतलब direction
क्या दोबारा बोलो?
lambda direction
नहीं, lambda का direction नहीं है. Lambda is the number of direction vector lengths that your point P is away from it.
how do you know पीछे होगा
हाँ, how do I know पीछे होगा आगे होगा? It depends on where is my D directed. मैंने the D that I took as an example is directed downwards. So all lambda plus values for lambda are giving me points on this side, and negative values of lambda are going to give me points on the other end. Are we good?